In the past, there have been some issues downloading and accessing and opening the data for this assignment in Google Earth Pro. So I'm just going to make this quick video showing how to actually do these things to get the data actually into Google Earth Pro and start looking at the different layers that are available in Google Earth Pro. So I'm here in the student view of the Canvas page for one of my Geography 100 courses. This probably looks similar, but maybe not exactly the same to the course you're currently in. But I'll just scroll down to the third module where this assignment is housed. That's the lithosphere, and we have assignment 3, investigating plate tectonics using Google Earth. So I click that. Again, as usual, the answers will be input into a quiz, but first you want to write them down in Microsoft Word or Google Docs or something like that. So don't press take the quiz yet. The first thing you have to do is get the Google Earth Pro software and then download the data for this assignment. So the first thing you want to do is download Google Earth Pro. Once again, you need to download Google Earth Pro on desktop. You can't use Google Earth on mobile or Google Earth on web. Some of the really important required parts of this assignment won't be visible in those versions of Google Earth. So I mentioned this in the assignment document, but I'm also mentioning it here. You have to go to Google Earth Pro for desktop and download it for either PC or Mac. This detects that I'm on a Windows computer, so it automatically launches the Windows download. But if you have a Mac computer, that's fine too. You can download it for Mac as well. Then you also have to download the data for the assignment. Google Earth Pro is a viewer that allows you to view all sorts of interesting data about the Earth, but we have what are called KMZ files that actually hold the spatial information in what are called different layers that we're going to be using in this assignment. So right here in the assignment, right here we have the required Google Earth data set, assignment 3, plate tectonics, Google Earth data, KMZ. So I click that. It may take a second. Right now my computer's loading. There we go. It prompts me to download this somewhere on my computer. You'll notice that it's already downloaded right here. This is my desktop. But what you want to do is make sure that you have it named as you'd expect. Save as type. Just keep it as a KMZ. That's what Google Earth Pro likes. And click Save. So I'm just going to name it 1 just so it doesn't overwrite the one I already have on there. Okay, so I clicked Save. My internet's going really slow today, so even though it's only 11 megabytes, it said it's going to take 5 minutes. I am just going to jump forward to accessing this data, so hopefully your internet's running faster than mine today. Okay, once you have Google Earth Pro and you have the data for the assignment, you want to go to wherever on your computer you downloaded these things to and access them through there. So I just saved both of them to the desktop. I figure that's pretty easy. So right here, this is a view of my desktop. And right here, I actually have a shortcut to Google Earth Pro, the software, and then the same icon for assignment 3 data, plate tectonics, Google Earth data. There's a few different ways of getting this data into Google Earth. Some people have reported trouble with this kind of primary way of doing this, but it's working okay for me, and I'm going to show you how to do this before showing you a backup way, kind of a second way to do this. So if you click this, the only thing that reads KMZ files is Google Earth Pro. It'll automatically launch Google Earth Pro with the data already in it. So I'm going to show that way first. All I do is double click this KMZ file. It's launching Google Earth right now. Let me make sure it's sized appropriately. Okay, so it took a little bit to load in this data and to load Google Earth, but here it is. It should look something like this. An important thing here, and I think where a lot of people run into problems just opening the data this way, is that the data isn't actually turned on yet. Your data shows up in this Places menu to the left. You have to turn on this plate tectonics data. So if I click this checkbox, turns on the data, again, it'll take a second to load, but it should be visible. It looks like there's a lot there, and I mentioned in the assignment guide that you probably want to turn off the things that aren't relevant at any given point in time, or you might just get overwhelmed by data. So here we go. Here's all the possible data layers that you can look at. This actually streams in earthquakes from the past 7 days from USGS. I'm going to turn that off. Past 30 days, turn that off. We actually don't need any of these earthquake layers just yet. So I'm going to turn all of these off. What we do want for the first part is this cross sections folder. So you can click the little arrow to expand the cross sections. Once again, it tells you to do this in the assignment if you follow closely down the assignment. And we're going to want to keep the age of ocean floors on. This is really important too. this shows how old any location on the ocean floor is, which is a really important indicator of when that area of oceanic crust was created, and also how long it's been around. Okay, I'm going to actually remove this data and show you another way to load in the data. So if it didn't work for you to just double click this data set and have it launch into Google Earth Pro, another thing you can do, I'm just going to close out of Google Earth Pro completely. You can open Google Earth Pro first, and this won't automatically load your data in. It'll just be like a blank globe. Your data won't be available in the Places menu to the left. You have to load it in. And the easiest way to do this is to just click and drag that KMZ file into the map window. If I do that, it should show up just like what just happened when I double-clicked the data. Okay, so I clicked it, dragged it into the map window, and let go of the mouse. It should be loading right now. So again, things just seem to be moving really slowly today, but there we go. Centers in that same location. Once again, you have to check the box to turn this on. And then again, you can expand that data to turn off the layers that aren't necessary right now, which are going to be those earthquake layers. But for starters, we'll leave on cross sections and we'll leave on age of ocean floors. I'll just turn off everything else to make it easier. All right, so I think the first part tells you to go to one of these cross sections. Let's look at the Atlantic. So this is kind of showing you what the actual lab expects you to do. And you can double click one to take you to exactly that location. So when I double click it, it takes us to this cross section. And in this case, I'm actually going to turn off the age of ocean floors. You can see this black line. The cross section is basically a line that goes across the ocean that will show you the elevation of all points along that line. So we're looking at the Atlantic cross section. When you double click it, it takes you here. You can turn back age of ocean floors if you want. But if you right click Atlantic like it tells you in the instructions and go to show elevation profile, you'll get this elevation profile down here at the bottom. As you move your mouse along it, you can see that red arrow moving across where that cross section line was earlier. That shows you at what point along this black line you're currently looking at the elevation of in this lower cross section. So some things to note here that are important for answering those first questions. If you go way over to the left over here, the ocean's not very deep there. You can see the red arrow off the coast of Florida in this part of the ocean that doesn't look very deep. So see that red arrow? It's showing like negative 800 meters, negative 900 meters, something like that. As you go all the way onto Florida, you actually get positive elevation. So the red arrow is showing you a location over Florida. It's going to be a positive value. As you move that red arrow out into the ocean, so it kind of gets hidden, you can hide the ocean floor age if you want, again, by turning off this layer. It really drops off, so you can see this drop in elevation right here. If you look in the map, that corresponds to kind of this light area compared to a dark area. That's basically shallow continental crust versus oceanic crust. But remember, either oceanic or continental crust can exist on any plates. They can have both types of crust. So this doesn't indicate the plate boundary. I'm just going to tell you that straight out because a lot of people mark this as the plate boundary when asked. This is the edge of the continental shelf. It's not a plate boundary. As we get down to the open ocean, it's kind of consistently deep over here. So look both at the graph and what we're looking at on the map. It stays pretty deep. Let's follow along a little further out in the middle of the ocean. Now again, look at the cross section. You can see that there's actually a ridge in the middle of the ocean. That's pretty important, and you should recognize what that ridge is from the figures in the textbook, the lectures, and the reading. So this ridge is really important for answering some of the questions, knowing what this ridge is, why it exists there, what it represents. As we keep going, the ocean gets deeper again. We're past the ridge now. We're moving towards Africa. And then once again, we jump up onto the continental crust, which is a lot shallower in the ocean, negative 100 meters here, until we're at positive values again out over Africa. So that's how these cross sections work. And most of this assignment consists of looking along these cross sections to identify important landforms that I talked about in lecture and that are covered in the book. Each type of plate boundary has landforms that show exactly what type of plate boundary that they are. So they're landforms that are characteristic of that plate boundary. A mid-ocean ridge is characteristic of one type of plate boundary. It's a very important location on that plate boundary. Other types of plate boundaries might have volcanic arcs or subduction zones and trenches. These are all important landforms you should know, and if you don't know, you should really look into the textbook and make sure that you understand them before trying this lab. Then at other points, you will be asked to turn the age of ocean floors on. This is really important. Anytime you're looking at data, information about that data will show up on the left over here. This is called the legend or the key. In this case, we have age of ocean floor with 0 at the bottom in red, and these purples at the top going up to 270 million years before present. These are the really old ocean floor areas. So there's a really obvious trend that you should be familiar with, again, from lecture and from the textbook, where we have these red values in the middle. That means there's a young ocean floor, and these blue and purple values along the continents, that's old ocean floor. This is really important for understanding plate tectonics as well, so it's going to be important to turn this layer on and off. At later points, you're going to be asked to look at things like plate names or plate convergence. Plate convergence shows you which way these different plates are moving. And for some of this exercise, you're going to be asked questions about earthquakes. So you're going to want to turn on the earthquake layers as well. So these are like major earthquakes. Each one represents 1 year, 2015, 2016, 2017. Again, they show up better if you turn age of ocean floors off. And also, a lot of times you have to zoom in to see them. They don't show up when you're all the way zoomed out. So here we have a string of earthquakes that interestingly correspond to that ridge. Again, these are things you should be familiar with. They shouldn't be completely new or seem completely random to you. So we have a steady line of these earthquakes in orange along the mid-ocean ridge. And importantly, at the left, we have another legend or key giving us information about these things. The color of the earthquake corresponds to the depth. Orange earthquakes are shallow earthquakes. In other places, we'll have earthquakes that get deeper. That'll be shown in yellow, green, blue, purple, or red. So over here in the Caribbean, we have another interesting pattern going on. Again, it's a fairly linear area of earthquakes, but they differ in depth. And that's going to be something to look at and talk about in the assignment as well.